Explanations helps you understand how the inputs to your model affect its prediction. They can be used with all kinds of models and data, including images, natural language, and tabular data with numerical and categorical fields. Let's start with images. First, I'm going to show you a simple example so you understand how explanations is useful for model builders. Then we'll look at a healthcare use case. I'll be demoing all of this from Cloud AI Platform notebooks. Here's a model that classifies different types of flowers. We'll send 2 flower images to our model for prediction. Looks like our model classified both of these flowers correctly. But what caused our model to make these predictions? Explanations can tell us which features were most important to even the most complex neural network. I can get explanations from any TensorFlow model deployed on Cloud AI Platform using the Prediction API. For image models, explanations helps us better understand which pixels in this image contributed most to our model's prediction. In this case, we're using explanations to validate that our model is performing correctly and generalizing on the right image attributes. From these explanations, we can see that our model is able to pick up on the shapes that are specific to these types of flowers. To look at how explanations can be used by model consumers, let's see how they can be applied in a real-world example. I also have a model that can classify images from eye screenings to determine if a patient has diabetic retinopathy, or DR, a condition that can lead to blindness if not caught early. This is an image of an eye with proliferative DR, which is the worst form. Without explanations, our model can correctly classify this as proliferative. But for a doctor confirming a diagnosis, a classification alone may not be enough. They likely need to know what led the model to make this prediction. Here is what our explanation service returns for this image. It is highlighting the areas on the retina which are indicative of this condition and helps focus the doctor's attention for a faster diagnosis. So now that you've seen how explanations works on images to help both model builders and end users, let's take a look at a model trained on tabular data, the most common type of data for businesses. For this example, let's say you're managing a bike sharing company and you need to decide how many bikes to have in circulation. We need to guess how long each bicycle might be in use. So let's predict the duration of bike share trips, given data like trip distance, start time, and weather data for the given day. We've trained the model by joining 2 public data sets available in BigQuery, London bike share data and weather. Here is some data on a bike trip that took 11 minutes. Let's send it to our cloud model and see what it predicts for trip duration. Looks like our model got pretty close. It predicted 10.71 minutes compared to the actual duration of 11. But what caused the model to predict 10.71 minutes? Here is what explanations returns for this particular example. These attribution values are all relative to the model's baseline prediction, which is what the model predicted for the median across all of our input values. Attributions with high magnitude were most important to our model. Positive attributions increased the predicted trip duration from the baseline, and negative values decreased it. So here we can see that the start hour of the trip decreased the model's prediction by about 1 minute. We could then use this to optimize bike availability based on insights across variables like time of day and weather. But as a model builder, it would be nice if there were a better way to see what explanations returns. The best way to visualize explanations for tabular data is with the What If tool, an open source tool for visualizing the explanations on our Cloud AI Platform model directly in a notebook. Let's try it out. Here on the x-axis, we see the predicted trip duration for all of our test values. When we click on a dot, we can look at the feature values for an individual example. We can also see the attribution values returned from cloud explanations for each input. For this trip, it looks like the distance and max temperature influence the model's prediction the most. The What If tool also lets us change these values and rerun prediction to see how the updated values influence what the model will predict. So let's try changing max temperature to 10 degrees Celsius, rerunning prediction, and see how this affects our model output. Looks like it decreased the model's predicted trip duration by about 2 minutes. AI Explanations is ready for nearly any kind of model across a variety of industries, from identifying important pixels in medical images to highlighting critical words and sentiment analysis, to showing reason codes for asset valuations. We're excited for you to try out Explainable AI on Google Cloud. And with that, I'd like to welcome Andrew back to the stage.